ওকে, ইউটিউবও আছে।
চেয়ারম্যান সাহেব এখনো খুঁজে পাইনি।
লিংক পাইনি?
না, লিঙ্কটা খুঁজে পাচ্ছে না।
ও ও,
আবার পাঠিয়ে
6
দেবো?
অক্টোবর পাঠানো হচ্ছে
হ্যাঁ,
link।
পাঠিয়ে দিন বেটার।
আবার পাঠিয়ে দিচ্ছি আমি, উনি পাবেন
এক্ষুনি
না।
পাঠিয়ে দিন, উনি খুঁজে পাচ্ছেন।
হ্যাঁ আমি পাঠিয়ে দিচ্ছি, আরেকবার পাঠিয়ে দিচ্ছি আমি।
বেটার হচ্ছে ওই দিনে একটা পাঠিয়ে দেওয়াটা বেটার।
হ্যাঁ,
একটা না রিমাইন্ডার যায় সকালে, আমি তাও ওনাকে
না,
না
আমি 6 অক্টোবর পেয়েছি, সেটাই।
না ওনাকে আমি এবার থেকে ওই পরে একটা
রেগুলার
একটা পাঠিয়ে
ওনার
দিন।
প্রবলেম হয় ওটা দেখে।
হ্যাঁ, ওনাকে পাঠিয়ে দিন আর রাজুকে পাঠিয়ে দিন, দুজনকে পাঠিয়ে দিন।
ওনাকে পাঠিয়ে দিয়েছি।
হ্যাঁ, রাজুকেও পাঠিয়ে দিন।
পাঠিয়ে দিয়েছি।
ভেরি গুড।
ঠিক আছে,
তাহলে চেয়ারম্যান সাহেব জয়েন করলে উই ক্যান স্টার্ট।
আমার ভিডিওটা দেখা যাচ্ছে তো?
হ্যাঁ, দেখা যাচ্ছে চঞ্চল।
না, আর প্রেজেন্টেশনটা?
হ্যাঁ, প্রেজেন্টেশন দেখা যাচ্ছে।
ভেরি গুড, ঠিক আছে।
তোমাকে দেখাচ্ছে, তোমাকে শোনা যাচ্ছে, তোমার প্রেজেন্টেশন দেখা যাচ্ছে, এভরিথিং ইজ ফাইন।
ওকে। হ্যাঁ, চেয়ারম্যান সাহেব জয়েন করে গেছেন।
ভেরি গুড। প্যানেলিস্ট, গুড ইভিনিং মিস্টার চেয়ারম্যান। চেয়ারম্যানের অডিও কি কাজ করছে?
না, চেয়ারম্যান সাহেবের অডিও কাজ করছে না।
অডিও ভিডিও দুটোই ওপেন আছে, কিন্তু কিছু কাজ করছে না মনে হচ্ছে।
হ্যালো
হ্যালো চেয়ারম্যান স্যার, গুড ইভিনিং।
হ্যালো
গুড
হ্যালো
ইভিনিং।
চেয়ারম্যান স্যার, গুড ইভিনিং। চেয়ারম্যান আমাদের কথা শুনতে পাচ্ছেন না?
না, হ্যালো
গুড ইভিনিং।
চঞ্চল, তোমার স্ক্রিনটাকে ফুল করে দাও, মানে প্রেজেন্টেশন মোডে
হ্যালো
করো, দেখতে ভালো লাগে।
হ্যালো হ্যালো am I audible?
Yes, we can hear you, sir.
Okay, okay, চলো।
Good evening, Mr. Chairman.
Yes, yes, good evening.
Mr. Chanchal, should we start? Just one more minute. It is
I think
6:09.
have you opened up the participant screen?
Yes, it is 21 as of now.
Okay, because I am not able to see the participants list.
Acha, why?
Don't
I
know.
can see. Click on participants. Chanchal, let's start, huh? Since chairman is here.
I think it's better.
Okay. Good evening, dear audience. Thank you very much for your participation. And this is our 16th monthly webinar. And we did on 27th August 21, we made a seminar on 5G Road to Reality. After 13 months, I think it is time again to say 5G a reality now. So that point of time, we had at least 120 participants. We hope more participants will join and enjoy the seminar this evening. May I now request Dr. Nirmal Das, Chairman, West Bengal State Center, to give his welcome address.
Thank you, Mr.
Over to Dr.
Chakraborty.
Nirmal Das. Yeah.
Thank you, Mr. Chakraborty. A very good evening to you all. Dr. Thakreji, our President of Institute of Engineers, Vice President Mr. Sandeep Kumar Dev, G. Ranganathan, Dr. G. Ranganathan, our Chairman, CATE, Professor G.S. Mundata, Chairman, Electronics and Telecom Division Board, Dr. Raju Bosak, Honorary Secretary, Engineer Ramchandra Chakraborty, Joint Honorary Secretary, our panel speaker, Engineer Chanchal Chakraborty, who happens to be the convener of this division as well as today's panel speaker, Mr. Santosh Gupta, Program Manager, Ericsson. He also will be associated, Mr. Chakraborty, our council members of the institution, distinguished corporate members, ladies and gentlemen. It is indeed my great pleasure and honor to be speaking here today in the webinar on 5G Reality Now, organized by the Electronics and Telecom Division of West Bengal State Center, the Institution of Engineers, India. Being the chairman of West Bengal State Center, it is my privilege to address the gathering of eminent engineers and technologists today. On this occasion, let me extend a warm welcome to you all, especially to our panel speakers, corporate members, distinguished guests, the IAI staffs, students, and other dignitaries. As we know, 5G technology is today's webinar theme. As officially this unveiled by our Honorable Prime Minister Narendra Modi at the India Mobile Congress in 2022, held at Pragati Madan in New Delhi during 1st to 4th October recently, 22. It represents the next generation standards of wireless communication, connecting devices, machines, business, and people together. In fact, by the beginning of 2021, 61 countries across the globe already had up and running commercial 5G networks. So where does 5G in India stands today? Would like to know. 5G network in India first came into conversation in 2017, when a high-level forum was set up by the government to chalk out a roadmap towards a 5G March India by 2020. Given the rather stop-start journey of 5G in India, which is now gathering pace fervently, however, as per the government and the Department of Telecom findings, the large-scale network infrastructure necessary for 5G network in India launch is still adequate, and we need to overcome several hurdles like low fiberization footprint, make in India, hardware challenge, high spectrum pricing, choosing the optimal 5G technology standards, differences in 5G brands, and so on. The potential of 5G in India is truly game-changing. Once implemented, it would be able to support up to 1 million connected devices per square kilometer, compared to just 22,000 per square kilometer under 4G LTE. With such unprecedented levels of connectivity and 5G internet, we will be able to transform education, healthcare, agriculture, and so on and so forth in rural areas particularly, while developing smart cities in the future and hallmarks of the futuristic 5G India. In fact, by 2035, the cumulative impact of 5G on the Indian economy could touch the $1 trillion mark. The 5G launch in India is estimated that at least 40 million smartphone users will be the early adopters of 5G in India within a year of launch. Despite these optimistic estimates, 4G will continue to dominate the Indian mobile connectivity scene for another 3 to 4 years, I believe, before 5G in India becomes commonplace. Today, we have a good number of panelists like Chanchal Chakraborty. Hope this webinar would cover all the possible applications of 5G and the challenges to make them suitable for Indian environment. Let us educate ourselves on the end theme and explore how this technology will be able to contribute towards our comfort living. I would like to thank you once again. Let us enjoy this deliberations today. Thank you. Over to Chanchal. Hey, sorry, Ramchandra Chakraborty. Hello.
Thank you, Mr. Chairman, for your welcome address. I just to add a few sentences on what our Mr. Chairman said. He already told us that this 5G technology was officially unveiled by our Honorable Prime Minister Narendra Modi at the India Mobile Congress on 1st of October in New Delhi. What it will give? It will provide seamless coverage, high data rate, low latency, and highly reliable communications. It will increase energy efficiency, spectrum efficiency, and network efficiency. With the progressive rollout of 5G network in our country, services over the next few years, 5G solutions will transform customer experience, enhance business performance, and positively impact people. The 5G will catalyze digital economic growth by ushering Industry 4.0 to enterprise efficiency and productivity. This technology will provide the user with smarter and safer solutions for cities, citizens, and businesses. 5G can bring transformational impact in various areas such as agriculture, education, healthcare, safety and security, significantly accelerating the socio-economic development of our country. Private network solutions will cater to the growing connectivity requirements at large facilities. Public safety will be enhanced by using 5G network and artificial intelligence. Hope the major players in 5G domain today in our country, Reliance Jio, Airtel, Vodafone Idea, will drive the ecosystem development in the country for faster adoption of services. A connected world with limitless digital solutions will soon be the new norm. May I now request, since I think none of the VVIPs are available today, maybe for various reasons. Chanchal, can you see any of? No, I think
No,
we are
no,
there.
no.
So may I now request Engineer Chanchal Chakraborty to start his presentation.
Okay,
Thank you, Chanchal.
right. Thank you very much, Ramda. Today we are in the fascinating world of 5G, which we are going to talk about 5G reality now. Now, for this fascinating journey, 1 minute. Am I audible?
We
Am
can
I
hear
audible?
you. We can see your screen also.
Presentation. Okay,
Okay.
right, fine. So today we'll talk about for 5G. We'll first understand what is 5G. Then we'll talk about 5G diversity of use cases and requirements. We'll talk about then what are the key 5G technology components behind it. Then we'll see what is the underlying network architecture, spectrum used, and 5G deployment phases. So these are the primary points we'll discuss today. First, let us talk what is 5G. Now, if we see that from the way to 5G, we started from 1G technology, though it has not been launched in India in 1980s, and it was purely a voice only, and it was completely analog technology. We started in India from 2G in 1990s, and it was predominantly voice and SMS, and later on data speed of 14.4 to 64 kbps got started, and it was end-to-end digital network. So more emphasis came for the 3G services. We started around 2003. Data speed became 2 Mbps. It was purely voice and data, multimedia, and digital end-to-end altogether. But people were asking for more and more data. So it was 4G which came, and it came around 2009 worldwide. The speed became around 200 Mbps, but this speed is not all across because the users are not experiencing this speed at all the facets, right? It was data only. It was IP technology. So this is the complete change in the platform. Here there was a voice and data. So for voice, one network was utilized. So that was known as a circuit switch. And for the data, there was another route. That was the packet switch, and which was going to the internet. Now for 4G, what has happened? This portion, circuit switch component, got abolished. The packet switch was there, and packet became the bearer, and there the voice was the value-added services. Data, it was pushing through this. and voice was predominantly given by the voice over IP protocol. So this was in the 4G it became, but people are thinking that they'll mange more. So they are asking for the next generation technology, which is now 5th generation technology, 5G. It got launched in 2020 in South Korea by SK Telecom. And the speed became, it is about maximum speed can be there, 20 gigabits. We'll see how it gets achieved. It is a purely data only. It is a broadband. It is a digital, and it is the one standard only. Now, how the things are coming under the purview of the 5G platform, we'll see next. So if we see the evolution of mobile communication, to repeat the earlier slide, purely it was analog type mobile voice communication. Then it became efficient voice to reach billions by digital communication. Then focus got shifted to mobile data in 3G. 4G, it became really a mobile broadband, and the government has decided to see that mobile broadband will be the speed which is more than 2 megabit per second. And then in the 5G, it becomes a unified connectivity fabric. For the next decade, we'll see the plethora of services under wireless platform. And we'll see what are those services. Now, need came. The need came because of the exponential growth in the data transfer. We started from 1G, what there was a negligible data speed 2. And on 4G, we know it 5G for more and more data. So the data speed now on the wireless become on the platform. 20 gigabit data speed, transfer speed possible. And on the next generation technology, it will be coming. It will be giving around 1 over wireless platform. Broadband experience were at it will be data handling or media handling, like say with video streaming, any kind of data, 4K, 8K formats. So the format also coming into picture. It will be smart vehicle detail later on. We'll see the critical control of remote devices and then an IoT platform. So all use cases, how those things are getting on the platform. Now in the European Commission, what they put a need set that of what 5G should be, it should have the end-to-end of the different kind of diseases, like water quality. Using the smart wearables, we'll see those monitored. A vehicle-to-vehicle communication will be possible. If the vehicle tries to other vehicle, it's possible. Vehicle moves with a speed than the threshold, it will be getting detected. So many things can, then they're not parking requirement. You must have seen that whenever you are going to some place, some kind of haphazard kind of, here what will happen is that whenever you want to park a vehicle, there will be some kind of FASTag kind of thing, which will be scanned over there by RFID. It will allow you to go inside, payment automatically getting deducted to your payment gateway, right? So those will be, and the biggest nowadays, whatever revenue getting generated, majority of the, but here the revenue will be collected and intermediaries will be completely be avoided. E-health facility where the smart wearables can also come into picture, like a who is sleep having the smart wearable. So during that, if there is any money or perspirating heavily, so the system will immediately to the nearby health center or those parameters will be preparing. It is a kind of heart attack or kind of that. So they will prepare the and the emergency vehicle. The will go to the person. He will pick him up and will be putting into there. Payments will be set through his automatic payment gateway. What to his home. So you see it will be easing out the life. Then there will be a domote will detail about this has gone out of control, and that is having the IoT devices. So the IoT devices will sense that, and it will be sending to the repair center number, and the repair center person will come and fix it, and the payment will be automatically getting deducted. Similarly, in the smart home, all his gadgets will be IP enabled, and there will be IoT sensors. The next generation all devices will be coming. Also, it can be uplifted also existing systems. So the next generation homes will be connected by this type of facilities. Then there will be a concept of smart grid. What happens in the normal grid, the electricity which is coming over there, the grid is not at all balanced. So some may be having the huge load, another grids which are there, they are underloaded. So what will happen? The load will be getting equally distributed by the load balancer, and it will be even out the tripping possibility of any particular grid which goes above the threshold. And if some grid gets tripped due to any technical reason, the automatically load will be getting distributed to other grids. So this is the sensing this thing, and it will be very much the requirement nowadays, because otherwise you will not be able to distribute the load evenly. So these are the concepts which came, and in the 5G infrastructure public-private partnership, that is known as 5G PPP, they told the concept that every house will be a connected house, everything will be connected thing, entire city will be a connected city, all the transport will be the connected transport. Like a person, suppose he is moving with a perambulator with a kid, the kid can be the kid, whoever is there, he can be connected with the nearby internet. The factory also will be connected. The school also will be connected. Offices will be connected. So anything and everything will be connected to the network. So with this thing, 5GPP is telling that the wireless capacity requirement will be 1000 times. 7 billion people will be connected all across the world. 7 trillion things will be connected. It will be saving 90% of the energy saving by the inbuilt technology. We'll see how it is. And it will be requiring almost zero latency and the perceiving the zero downtime. Now the question comes, what is latency? Now suppose this is your tower and this is your handset. So the tower is housed with say 5G radio device, which is known as G Node B. So we tell it as a G node B. The nomenclature is the next generation or the new radio, whatever we'll tell. So the G node B comes into picture, and this G node B, whatever time it is taken from the handset to come to the tower, this much time is known as the latency. So the lower the latency, the more will be required for the some particular type of application which is of the mission critical type, like AR/VR control devices, like the places where you require the remote surgery kind of thing, where you require the automated car driving. So all such requirements will be having the less latency. But whenever the different sensors are getting connected for the IoT platform, it may not be that much prominent, excepting some few mission critical cases. Or maybe you want to transfer data at a high speed, it may not be requiring that much speed. Now, the 5G diversity of use cases and requirements will be this has been given by International Telecom Union, and R stands for radio. So ITU-R defines the specification along with HC that the peak giga rate will be of the order of 20 gigabit, whereas in 4G it was 200 MB, and in the 4G advanced it was 1 gigabit speed. But here the maximum speed can be 20 gigabit. User experience data. That means when the user is moving away from his tower and he moves across the edge, which we tell as a cell edge. So when he goes to the cell edge, he will be getting 100 Mbps data, which nowadays maybe 2 Mbps, even might be less sometime. And in 4G advanced, the speed was envisaged to be 10 gigabit per second, 10 megabit per second, sorry. Spectrum efficiency will be 3 times. Spectrum efficiency means how many bits can be transferred in 1 hertz spectrum. That means if the spectrum is 1 hertz, and if you are sending, say, 30 bits per second, so the spectrum efficiency will be 30 bits per second per hertz. So as more number of bits will be passed over here per second basis in a given spectrum, so spectrum efficiency will be higher compared to 4G, and it is the 3 times of that. Now in 4G, the maximum vehicle speed which can be handled is the 300 kilometer per hour. But here in 5G, it can be a 500 kilometer per hour, considering all bullet trains and the different type of trains and other things. We talked about latency. In the latency, we have seen in the LTE or the 4G, it was 10 milliseconds. And here it comes as 1 millisecond in 5G. And in the 6G, it will become 0.1 millisecond. Now, so far as the device connectivity, in 4G, you can connect 1 lakh devices per square kilometer. And here you can connect 1 million devices, that means 10 lakh devices per square kilometer. Energy efficiency is 100 times compared to 4G. We'll see how. And in building coverage, the capacity will be 10 times the capacity which could have been achieved in 4G per square meter area. So whenever we are covering the in-building solutions, indoor coverages in the shopping mall and others, so we designed the network like that per square meter, how many megabits can be accommodated. So these are the basic facets of the things which have been thought of that 5G will be able to cater to. Now, if we see 5G, what is 5G? 5G services can be clubbed into the three prominent verticals, which can be thought of vertices of a triangle. One is the extreme mobile broadband, and that is known as EMBB. It gives a high throughput, and the throughput is of the order of 20 gigabit or so. Everywhere's minimum speed will be 10 megabit per second. It will be 10,000 times more traffic. And as it is moving towards this direction, what happens? The speed may not be that much required, but where the latency requirement is very, very important, and it will be of the order of 1 millisecond latency, where the application will be autonomous car driving, remote control of the robots, Industry 4.0 requirements, VR gaming, and all such stuff. If we come much towards this thing, these services will be catered to a particular vertical, which is known as ultra reliable low latency communication, and this is basically URLLC. So here it must be very much reliable, means there cannot be anything, no link should be disconnected at any point of time. So we have to design the network in such a way there cannot be any downtime, number one. And low latency means the time it will take from user to go to the tower, that will be about 1 millisecond, because otherwise whenever car is moving, if it cannot connect to the network, what will happen? It will collide. So this is undesirable, and we have to fix all such things with this kind of parameters. Then another vertical which is of importance, that is the massive machine type communication, which we tell as MMTC. This is nothing but the IoT sensors connectivity, which will be connected like smart city cameras and the sensor network. There will be a lot of sensors which can be connected across. We'll see those. Since it will be there prominently, might be in the remote areas where you may not get the sufficient, the battery, the power charging capability, or the power may not be available for days together. So we have to run those things on battery, and the 10 years battery should be there. So the battery life should be for 10 years. And it should be with ultra low cost. And there will be a huge number of devices, as we told that device concentration will be 1 million per square kilometer in 5G compared to 1 lakh devices per square kilometer in 4G. So we see the 5G services can be categorized into throughput, so that is EMBB services, latency and reliability, so that is the URLCC, and the devices, cost and power, that is MMTC, which is nothing but the IoT services. So the services here you find that in the 4G, it was only the throughput. But here it is much beyond that. Though in 4G, there was some kind of devices which were connected, like in the narrowband IoT, which is of not that much important, which cannot be adopted to a huge number of devices, and all the devices, all types of sensors cannot be connected. Here, the huge number of types of the sensors can be connected to the network. So if we see that for the enhanced mobile broadband, so these are the parameters, almost all parameters: network energy, efficiency, area traffic capacity, peak data rate, user experience data rate, spectrum efficiency, mobility are very, very important. But connection density and latency is not that much important. But for machine type communication, the network energy efficiency, yes, to some extent it is okay, but majority is the connection density. It is important. Latency and other speeds and other things are not at all important. But for Ultra reliable, low latency communication is the mobility and latency are important. Other parameters are not important. So you are finding the different type of services are they coming with the different sets of requirement. How to handle in the network. We'll see later how it is handled. We'll see by the concept of network slicing. We'll discuss that. Now, if we see the use cases in 5G, you'll be getting the 3D USD telepresence, holographic images will come out, and the professor can talk from the distant end, and he will be appearing just before the students. And one use case was displayed in the IMC this year, that the distant the students are there and the holographic images are coming over there. So that's a very good use case, and the people will be elated. And similarly, the video conference and other things can be with holographic images coming. So this will be giving some kind of real-time experience. Then another concept which comes is the tactile internet. Means there will be a transparent type of glass will be there. And the glass is prepared with a particular material. When you touch it on the other side, this side, whatever devices are there, you'll be having a feeling on that. We'll talk about that. Then you can have ultra high density video streaming. So here nowadays, the 4K videos or 8K videos will be coming into picture, and that will be changing the video experience to the users. Now, the demanding conditions of the venues. So suppose this is auditorium where the people are, so many people are over there. They want to take the photographs of their players or they are during the play, the video they have taken, and immediately they want to send to their friends or put in the social media. And you can imagine what kind of load will be getting generated. So mere presence of the 5G, it will be able to handle those kind of data load over there. It will be acting as a broadband fiber to the home. You have seen the broadband, the devices, whatever is connected in your house, the ONT devices, it is getting connected by the fiber. Now here the wireless kind of devices has come, which will be connected over here. And the devices which has been shown this year in the IMC 2022, that this type of devices which are the 5G enabled, so it will be activated wirelessly, and it will be giving the broadband experience in your home or wherever you place, and it will be giving a huge experience. Then you can have the experience like a virtual reality. So you will be having this type of gear you put over there, and then you can see and can see the films, which is not real, but it will be appearing to be real, and you will be thinking that you are involved in that, right? So that is the concept of virtual reality. You can, if you go to the different shopping malls and others, you will be finding the kids are with this type of gears and they are enjoying the different kind of videos. So 5G will be giving basically the backbone for the access network to get those data online from the internet, and he can, sitting in his house, he can enjoy the thing. Similarly, the concept of smart cities will be there, where all the houses will be connected by the IoT sensors, and for all streets, like the street lights, there can be all the nursing homes are connected, all the buildings are connected, and in such a way so that anything and everything, whenever there is a need, the service will be available. Like the smart homes, which is a part of the smart city. So what happens is that in your house, all the devices, any kitchen appliances or your home appliances are connected on net. And if there is any anomaly, or if you require, you are not at home and you refresh the refrigerator, it finds that in the particular rack where the milk can is there, the milk is empty. So what it will do is that it will automatically send the information to the milk supplier, that so that you can deliver the milk. Of course, under your permission, payment will be done automatically. and the items will be coming to your home. Similarly, there will be our utility metering. So it's a frequency, whether 15 minutes, after every 15 minutes, 30 minutes, or 1 hour, whatever frequency you have told. So the electricity consumption, whatever you are consuming, it will be your meter readings rather, will be going transferred to your electricity company. So what they will do, they will analyze it, and over the some few days after analyzing, they will find that in a particular hour, maybe during the peak hours, you are utilizing, say, your washing machine and others. So that will be consuming a huge amount of electricity. They will tell you, okay, you utilize in the off-peak hours and you will be getting discount with that. What will happen? That you will be your electricity consumption will come down, your electricity bill will be less because you in the off-peak hours, he has given the discounted rate. What is the advantage for the electricity company? Because electricity company, they are utilizing different power plants, and those plants, maybe a consumption is varying. So what they are trying to do is that they want to even out the consumption. Say maybe during off-peak hours, he is using the 2 plants are up, and in the peak hours, 4 plants are to be made up. And then again in the night when the consumption goes down, he has to put down this plant. So shutting down the plants and then again bringing it up, it requires a huge the job challenge, and the consumptions as well as a lot of issues are there. So he can remove all such pains, and if he can even out the consumptions, so customer is happy and the operator is also happy. So that brings the win-win situation. Similarly, as we have already told, the bangles nowadays, you must have seen that people while jogging, they are putting this type of smartwatch and they see how much calorie got burned, what is the heart speed and all such stuff automatically coming on these things, and how much kilometer you have walked, everything comes. In the remote sensors and actuators, what happens? In your house, when you are coming back after a hectic day, so you want to see that your air conditioned temperature should be at, say, 24 degrees centigrade. So what it will do, that from the GPS location where you are there, and based on the travel path, and based on your car speed, it will calculate how much time you will take to reach home. Based on the time, he will calculate and make your device on, so that once you are coming home, you are getting your all such in that particular temperature. And at that time, suppose you require to take bath after a particular time, so it will put the geyser on, and automatically the water you will be getting warm water. And at the time, say you want that some fruit juice and other thing, it will give you the intimation at such and such rack, your fruit juice is available and you can have it. So without anybody's help, you will be a self-controlled, self-supported person with the informations which are available in this digital domain. And that will be converting your life very, very easy and that can be told as a digital life. Similarly, when the objects are moving for the, say, logistics movement, you can track where your truck is lying, where your car is lying. So based on that, you can find out whether that guy is sleeping or he is waiting somewhere, and whether he has given the items, handed over the items right in time or not. So this will be increasing the performance of the logistics operator. So what would happen is that these are the IoT based. So definitely it is power efficient, because as we told that it is a multi-year battery life. So what ITU has given a standard of 10 years, right? Since it is a very low complexity device, because for every work there is a particular device and it is a very low complex. So the cost is abruptly low. And as we are covering the entire network across the road or ubiquitous coverage, so you will be getting the long range or the deep coverage zones. So in this way, you can connect anything, anywhere with efficient and low cost communication. This is very, very important. Now let us see what are the other 5G use cases. A kid, there is a video live streaming is happening, and the person who is playing, the kid wanted to go, but the kid has not been allowed to go there by his parents. So what he is doing is that he is wearing this VR glass, and over the 5G bearer path, he will be getting the live VR streaming in his house, and he can enjoy the entire content. So that's a different thing. As I was telling, that the 3D holographic image which will be coming over there during the presentation, suppose you are giving a presentation on the some car design and others, and where the particular two-dimensional image is coming, which is not possible to be understood what is the look and feel of the car. But if you get the holographic image and it can be moved in a 360-degree pattern, so you can right away can see how the car looks like, all the product features, and the marketing guys can make the marketing plan accordingly. And wherever they want to give a presentation to their clients, they can give this type of 3D kind of presentation, which will be adding tremendous amount of value in this. As I've told also, the holographic, this type of meeting can be extended for education purpose or in the pace of the healthcare and anything and everything over there. Now we'll talk about the augmented reality content. The one application can be AR-enabled animal book. So the kid was who was using a boring animal book, only the photographs and all blunt information over there. But if he uses this AR gear, what will happen? He himself will be there with these animals, though they are virtual in nature, and this person and the animals which are completely virtual. So actual person and the virtual gets compiled over there, and there will be a thin line over there which is separating the actual and virtual world, will be giving a reality, and that is known as augmented reality. And this augmented reality nowadays are utilized in the different applications we'll see further. Now, automated car driving, whenever the guy moves, you see that if some guy is reading book while the car is moving. What is happening is that there are a lot of sensors are there, and those sensors are getting activated, and we'll be seeing that the car is getting. We are having a particular slide where we'll discuss it separately. Now let us focus on the VR remote control. As I was telling you, over this tactile internet, whenever you are touching the screen, you will feel that the robots which are utilizing this, tightening these nuts and bolts, whether that is properly done or not, you can have a complete feeling. So the feeling which is virtual in nature, so that's why it is virtual. You can have a complete control like the robotic surgery or remote surgery possible from the distant edge, right? So we can do like this. Now you see the remote surgery. Some person is there, put his microphone on. Can you switch off your microphone, please? Please switch off your microphone. Now we'll see the remote surgery. The doctors are not there at the distant end, where it can be a rural area. You are seeing the heart is there. And the rural area, the rural health clinic or somewhere where you cannot get all such facilities, or the doctor may not be that much expert. So on the 5G will be giving the BRR path like this, where his phone and all the reports by his sensors, by the different instruments, and there will be the different cameras, and there will be robotic arms will be there, which will be controlled by the the remote expert surgeons. So those surgeons will be getting all the inputs, whether all the parameters are okay or not. Accordingly, the guidance will come. The guidance can come on the by simply talking over there, or there can be an augmented reality over here, where he will be seeing the operation area and the line by line instruction will come step by step. And he will see the 3D image of the entire thing virtually. So that will be giving the different dimension where a person who may not be expert in a particular surgery, but with the help of this automated platform over the 5G, he will be able to perform the remote surgery. And see, the doctors can see at the distant end all the parameters from the distant end, and based on that, they can take the decision. 5G making it possible. So all the kind of critical services like ultra low latency, the wireless broadband gives the high bandwidth. The sensors are giving with a low bandwidth, and the live streaming is possible. So those will be coming in the 5G platform over the different network slicing. So over each slice, the different paths will be getting generated, which will talk, and the 5G gives this kind of facility, which could not be given by any other generation of the network, earlier generation of the networks. Now we have seen during the pandemic time, the e-learning, and since our networks, thanks to the 4G deployment, the 4G deployment has enabled the high-speed data where the student has taken the remote classes by his teachers. And you see, this is one Harvard Medical School snapshots where you can see that the different type of chromosome variations in tumor cases, and you can detect that particular tumor location by seeing the abnormal pulses. Here you see the medical education can be, suppose you are giving to the kids. The kids will be using the smart glasses, and the smart glasses will be giving a reality that the particular person with the different kind of, his muscles and the different organs, and it will be from the 3D effect, and it can move in a 360-degree fashion, which will change the education type altogether. So that will create a complete revolution in learning. As well as we have told in the 5G, the another application can be the holographic image transfer, via which the teacher who is teaching over there, so she will be simply coming out and appearing to be real, which is the holographic image which has been produced. That this thing has been inaugurated in IMC 2022 by Honorable Prime Minister. Now you see that there are the plethora of the smart solutions. We have talked about the smart city. This is the smart transport, where all the devices can be automatically connected. There, all the traffic lights are under the wireless connectivity is there over the 5G platform, and all the devices to device communication is possible. Even the wireless, when the automated cars will come, that also will be moving flawlessly by this type of smart transport arrangement. We can see that another, that is the industry 4.0 or 5.0, where the different kind of wearables will be giving him kind of tablets tab will be there, where the automated information will come, whether the machine, whatever the items which are getting produced over here, it is coming with the proper quality or not, and he can see it and can take the appropriate decision. Here the computer vision will be coming into picture. So the computer vision camera will be there, and the particular item produced, it will be taking its snaps, analyzing it, and compared to the quality parameters. And if it is not, then automatically it will tell that the things are not in proper shape. There will be machine analytics There will be different IoT sensors for the robotic arm movement. There will be unmanned truck. With the truck will be under automated movement without any human being driving over there. There will be a special lane over there. All the consignment will be stacked over there over the RFID sensors, so that whether the correct material has been stacked into a particular correct vehicle, so that will be analyzed. Like there will be a machine lifting, or the items can be lifted by the robotic arms, and all such stuff will be over there, which will be managing the show. And there will be a smart packaging, unmanned vehicle, and there can be unmanned the drone also. So the drone, what will do, it all can also lift it material which are there on the higher side of the almirah or the rack. It can take it and they can stack it, or there on the top, it can take the material and can put somewhere else. So this is the thing which is going to change the completely scenario in the industry. And all such sensors, even in the production platform, all the equipments which are connected with the centers, the data will be taken out, and that will be going to the grid computing. And then from the grid, it will be going to the basically some cloud computing. But there the big data will be there, and the big data will be accommodating all kind of data. There will be AI analytics. AI analytics will be analyzing, and it will be having the predictive type of maintenance, that before the equipment item goes down, it will tell that this particular machine or this particular module of the machine is going to become faulty next to 3 hours. So it will go to the floor technician, floor manager. Immediately they will take the attention, they will take action, and the machine will be survived. So machine will not go down. So this will save the machine, increase the operating efficiency, and the production cost will be coming down, because if the machine goes down, then it will become havoc to the operation thing. So, and it will be increasing the efficiency of the plant in terms of the production, the products getting manufactured. It can be delivered right in time, which will be amplified by this kind of the smart truck, the smart packaging, the quality checking, automated quality checking. So all such stuff will be enhancing the capability, and that will be increasing the operating efficiency. Then you see in agriculture, there will be a lot of drones will be there. What it will do, they know that the color of the particular, whatever the produces are coming, the color of the leaves, whether it is green or it is getting pale. So whether the proper kind of water is going, whether the proper kind of nourishment in terms of fertilizers are going. Sometimes fertilizers are put in one area more than the other areas. So the precision farming tells that it is completely separated into the different areas, and the drone will be deciding over here by utilizing the camera, and camera will take the photographs, analyze where the water should be sprinkled, where the fertilizer should be sprinkled, and to what amount. So this is very much important. With this thing, that will be giving the augmentation in the production of the crops, and there can be an interface over there, over the mobile, which can be completely governed, and the different vehicles and this type of drones and the devices can be automatically be controlled. There will be water sprinkler over here manually. So the lot of water gets wasted because the water carries so much amount of fertilizers, and it is taking into the nearest pond, and the pollution comes. So what it will do is that 70% water gets wasted. So it will be controlling, nobody is required. It will be automatically giving the water as per the requirement to the exact quantity. So this will be application for the smart agriculture. Smart city, we have talked that everything will be there connected, and that will be building the tomorrow's cities. So a lot of smart city applications are nowadays coming with the smart health in picture, which will be a grid with a smart hospital, that the emergency response and the smart home, smart infrastructure, smart gadgets, robots, technician, doctors, everybody is connected. And not only that, the medicine shops also will be connected. So wherever the medicines are getting prescribed, where are those available? Those information also will be given, and you do not have to run from here to another places. By single clicking the on your tab or in your laptop or in your mobile, you'll be able to get all the things, and all the parameters can be monitored by the nurse. And even sitting at your home, you can get the patient health monitoring status, and all the data are stored as the patient health record. And later on, whenever patient goes, he does not have to narrate right from the beginning, only telling that ID, patient ID. The computer will be automatically be connected. Nowadays, the devices have come that by the thumb, by the retina scan and by the face scanning, the device will be automatically telling you what are the health records. So these are the very much important, which can be integrated over here. As we have talked to the smart grid, here it will be the different kind of energy, maybe the wind energy, maybe the solar energy, maybe the nuclear plant, maybe the thermal power plant, or maybe anything, the blue hydrogen or any kind of things which can be coming over here, and those will be automatically be distributed effectively across the electricity network properly, so that the smartness in the grid comes into picture. As we have already told that there is a specific application for the vehicle to vehicle communication, and the V2X means it are coming into the vehicle to vehicle communication. That is, one vehicle can communicate with another vehicle, and it can see how much distance it is there, at what speed it is moving. It can calculate everything, and accordingly takes decision. Similarly, and then question comes that cannot be any overtaking or any kind of thing, because that is also getting monitored by the cloud network. Now there will be communication from the vehicle to the pedestrian or the cyclist, and this cyclist or the pedestrians are getting monitored how far it is there, and whether he is on the zebra crossing or any other object, whatever is there, it gets monitored. It's because of there are the different computer vision cameras are over here, different cameras, different sensors and radars, leaders, all are there. And what they are doing is, here the light detection and ranging radar is there, leader radar. So it detects that how far it is, at what speed it is moving. Based on that, it takes the appropriate action. Here he sees that whether there is any object over here, whether there is one cat is crossing or any other person is crossing, whether the cycle is moving, anything. So it takes that information, takes the photograph of that, and there is a computer vision algorithm. So he gets connected to the nearby cloud, and it is not the actually cloud, it is basically a grid or the edge computing, so, or the fog computing. So these are there will be every 50 meter or 100 meter, these grids will be there. So which basically this will be connected with the, the requisite amount of the CPUs, the amount of storage devices, and the connectivity devices, and necessary AI analytics. So it takes immediate decision that once you have taken this, what is that particular object all about? And the typical AI algorithm is utilized, neural networking algorithm utilized. This is known as CNN. That is, the convolution neural networking is utilized to analyze that what is the particular shape and the particular person or who it is there. So it analyzes that. Similarly, there will be a V2I communication, that is a vehicle to infrastructure, that will be communicating to the traffic light. It analyzes the color of the light by the same CNN algorithm, by the computer vision algorithm, and from that we'll be able to know whether he should go or he should stop. So this grid information, all such grids data will be going to the further to the cloud, and cloud will be taking some analytics data which will be getting communicated. But if it communicates at a very the cloud will be taking some time, but by that time some accident can happen. So because of that, you have to communicate to the nearby grid where our small cells or towers will be there, and this time will be about 1 millisecond. So this is the latency, that is the requirement, and this will be a required point. But in the 6G, it will be 0.1 millisecond. So further, it will be going down to analyze it in a different direction altogether. So this is all about the automated car driving movements. There will be mission critical networks. Basically, whenever the person it protects the property and saves the lives, because you know that anything and everything can happen in the emergency situations where the human lives are endangered. So the 5G can appear as a savior over there. So it can detect all the informations, or it can send, say, suppose in the coal mines, in the places and mines areas specifically where the human lives are endangered, where you can put the robots. Robots will work, and if there are some persons are working, you can send the robots to save the human lives. Who will control the 5G network? Similarly, the railway signaling is now going to be changed by the 5G signaling, by the real-time sensors and information sharing. So with that, it will be giving a much more, the comfort, and there will not be any delay in the signaling. Now, sometimes there can be fumes can be generated, or there are a requirement where the human lives, I told that they are endangered. So you can send the robots to send, or you want to sprinkle water. So you can put a lot of drones to be there, or drones rather, they can sense early and they can send the alerts, and immediately the ambulance people or other people can move over there to save the human lives. So this will be giving the services on the 24/7, and where the normally people cannot move. So in those areas, this can be utilized. Even it can be utilized, people are thinking to utilize in the areas, the battlefield or like that. Now, so we have seen the 5G service portfolio. The HD voice crystal clarity is there already. That has been done in the 4G and 5G. It will be almost same. There will be IoT in the same of that is the industrial IoT. So IIoT will be implemented. There will be enhanced mobile broadband in terms of very high speed. We talked about e-health. We talked about medical records keeping on the cloud. We talked about e-learning. This is the UHD type of ultra high density, like 4K, 8K traffics. And we have seen the different sensors. The sensors, whenever sending the data, they're sending for a very fraction of time. And there will be a bursty traffic. Say, suppose he has sent now here, and then the device will sleep, and then it will up. So the amount it is transmitting data are very small amount of data, and for a very small amount of time. And then again, it will be activated after a particular time whenever it wants to send. So considering this bursty traffic, you can see that the power consumption will be much less compared to the other kind of confirmations. Now you see that the facial recognition, as I told you, the V2X, the intelligent drones can be utilized for the security purposes. You can utilize the VR cameras, the smart grid, augmented reality, air-based navigation. So all such stuffs are in reality. So what is all these things? The 5G use cases, we have already seen that 10 gigabit or 20 gigabit speed, 100 megabit speed everywhere, latency 1 millisecond, 10 years battery life, and 10 times the connected devices. And if you see the global deployment, 61 countries, 144 operators already deployed, and other operators are in pipeline. So after over some years, the 5G will be covering up the entire globe. So let us see the technology components. The first technology component, which will be coming over here, now it will be the millimetric wave. The millimeter wave is from the around 20 gigahertz or so to 300 gigahertz and like that. Now, if you see that the light speed is 3 into 10 to the power 8 meter per second, and you know that the velocity is equal to frequency into wavelength. So if the frequency is 30 gigahertz, we'll find the wavelength will be of the order of 10 millimeter. And if the frequency becomes 300 gigahertz, the wavelength will become 1 millimeter. And since the wavelength is of the range of millimeter, and that's why it is known as the millimeter wave. The millimeter wave, first this concept has been studied by Indian scientist in Presidency College, Calcutta. His name is Dr. Jagadish Chandra Bose. And IEEE has now accepted his contribution and the seminal contributions in this era. And it is a proud moment for all Indians that this has been highly acclaimed. His work has been highly acclaimed. Now we see the low bands are basically needed for coverage and high bands are for the high data rates and capacity. We'll see that these things are in reality. So we'll find that the frequencies of up to say 2.1 gigahertz or so, we are utilizing the FDD, sometimes up to 2.7 gigahertz, the FDD frequency division duplexing we're utilizing. But on the higher frequencies everywhere, the time division duplexing, TDD, is getting utilized. Now in the millimeter wave, we are utilizing all this kind of TDD technology. Now why we are going for this millimeter wave? Because these are the new and less used band. Because you see there is a completely, these lower bands are completely filled up. So these are the virgin bands, and where what you can do is that you can get a huge amount of spectrum. That's why all operators you must have seen are jumping over this particular frequency domain. But can all the frequencies be utilized? No, because there will be different kind of absorptions by the dry air and water vapor, and total, the attenuation will be following these curves, and you will be finding where the attenuation is low, those windows will be basically getting utilized for millimetric waves. So the millimetric waves are such band where every band cannot be utilized. So that's why you must have seen that the bands like 26 gigahertz has been allocated, because here the attenuation is low. So 26 gigahertz bands have been allocated to the operators. We'll see those things later. Now there is a concept like massive MIMO, and we'll talk very fast about this MIMO. So MIMO concept means that a multiple input, multiple output, that different type of parallel channels have been framed. Suppose you want to send 100 MB data, so you can send, if the channels are having good performance, so you can send 50 MB here and 50 MB here. So obviously the time taken will be half. So the throughput will become faster. So what you will do, that suppose 50 is sent here, 50 is sent here. So in the same time, 100 Mbps will be coming. Whereas if you send 100 Mbps over this channel, the time could have been taken double exactly. So the time is getting halved over here. Now you see, sometimes the channel, some channel is good and some channel is bad. So over if the noise is crippling some channel, So that channel will be avoided and all the information will be passed through a particular channel. And this is known as a beamforming. So in the 5G, what happens? There will be a massive MIMO. In the 4G, there was a ubiquitous kind of coverage because the beam width is very spread, like 65° is the beam width. But here the beam is very narrow. So it goes narrow and it goes for long distance. So it will not cover here. It was covering all the devices, but it will be covering a particular device. And it will track the device and it will be connecting. So what it will do is that first of all, the interference becomes less. Second becomes that whenever you are passing these informations like this way, you are saving huge amount of energy. In the 4G, whether customer is there or not, you are giving the services, but here it is not. And as the number of channels are getting increased, the capacity will be increased and W becomes basically the bandwidth. So as the bandwidths are more and more bandwidth, your throughput will be more and more number of channels you will be getting as the massive MIMO capacity is getting more and more. So your throughput will become more and more. So that is basically you are getting more throughput in 5G by massive. Let us see further. If we see the 2 trans and 2 receive antennas, so you will be putting in the rural areas because your capacity will be more. But as you see the 4x4 MIMO, so as a 4, it will be coming as a 4. So the throughput will become more. As you are going for 60T, 60R, so throughput will be further be increased and it will be covering a huge number of customers, maybe a stadium and kind of that. So depending on the type of applications, you will be deploying this MIMO kind of thing. And as the MIMO ratio, that is the number of trans and number of receives, antennas are getting increased and increased, you will be covering a more number of customers and the throughput also. So what will happen is that here the 4G antenna, here it was a passive antenna. It was getting connected with the copper cable or coaxial cable. Here the remote radio head, which is basically the trans and receivers. And these trans receivers are connected with an optical fiber to the baseband unit, right? But in the 5G, all the things have been combined. So eliminating this copper cable and it has become like this. So it will be giving the different kind of directions of your propagation paths so that the huge amount of customers will be connected. We'll see that further. And as I have told, the antenna elements as well as the transreceive devices are just looking like an IC circuit. They are put, so huge number of channels can be provided over here. And I have taken photographs of Rosenberger antenna. You see that this kind of picture it gives, and it just looks like your PCB. Now the small cell, you see the normal macro cell, if it is connected, you see if the building and other things are coming, you cannot give the connectivity at the back, right? Here you cannot give connectivity. Here the people cannot get connectivity because of the high absorptions. So what it will do is that you can put a small cell all across the places, which will be giving the coverages. But what happens? The small cells will be operating in the millimetric wave or the higher band. As you are moving on the higher band, so the path loss will be a huge one and the distance covered will be very less. So a typical coverage will be 50 to 100 meters by a small cell. So you have to put a huge number of small cells and it looks typically like this. You can put on this an electrical pole, and this type of 2 antennas on the 2 directions will be covering this side and it will be covering this side. So this is a typical implementation of the 5G small cells, and it will be weighing up to each small cell will be weighing up to around 10 kg, 15 kg to 20 kg. So as I told, in the 4G, you are covering all the places and the users will be getting interfered over here. So whether you are customer is there or not, you are giving coverages. Complete useless. So what you do is that if there is an user, you give the coverage. And if the user moves from this place to B, the beam will be sweeping, right? So that is the major thing. And the beam will be in such a way that this beam and this beam and this beam will never interfere. What will happen is that, say, suppose you are having two antennas and two antennas, you are combining, so you can support two users. But here what happens? If you are combining so many antennas, the antenna will be giving a very narrow beam, but for a long distance coverage, and you can sweep the antenna if you change the phase of this particular input parameters, right? So the antenna will be moving. So it will be giving a sharp beam. So there will be this type of coverage. And if the customer is not there, he's switching off. So beam also will be switched off. And if there is no customer, all the beams will be switched off. So the conservation of energy is possible. So you see that my small antenna number array size is small, so it will be giving wide coverage. But if the number of antennas are more, it will be giving a sharp coverages. And for the long distance, what happens in the 4G area, if there are two antennas, if you are not optimized properly, they will interfere each other. But here, what will happen if this antenna is giving these beams and these beams, they are coordinated in such a way that nobody interferes each other. Because of the low interference, your throughput will be getting increased. So as we have seen, the antennas are having two type of beams. One is the vertically polarized beam, another is the horizontally polarized beam. So what will happen? Say, for example, here the 64T64R, suppose they are giving 16 beams on the vertical polarized direction and 16 beams are in the horizontal polarization. It can be changed by nowadays artificial intelligence applications. So the vertical beams will be covering the high-rise buildings and the horizontal beams will be covering this type of coverages on the road or the 2 or 3 or 4-story building, like the customers. So this will be giving a same antenna will be giving coverages on the high-rise building and on the pedestrians. And you are utilizing the mobile edge computing. What happens is that whenever a particular type of applications you are doing, if your handset is not capable, so it will be taking a huge amount of time or it will be a partial loading. So what you do is that you are putting an edge computing where you are putting all applications and data. So it will be getting loaded faster. It will be having a huge application in our network. Now we'll talk about the network function virtualization. Another very much important in the traditional equipment, what has happened, a particular type of server is put here and the software is bundled with that, right? And suppose this capacity is overloaded, and if I want that underloaded capacity here, I cannot utilize. So what they told is that to remove this purpose-built hardware and put the generic hardwares like IBM, HP or like that, and put software parts. So what you do is that your hardwares, whatever hardwares you are putting, those will be virtualized by putting over hypervisor, or nowadays the Docker container comes. It makes the virtual computers, and virtual computers will be allocated different softwares. So the software portion is dealing with the hardware based on the requirement. The virtual machines will be getting allocated, softwares will be coming into picture, and entire thing will be orchestrated by this. And we tell in a network function virtualization, it is the virtualization, softwareization, and orchestration. And this orchestration is nowadays managed by artificial intelligence. Now, question comes that why the software-defined networking or SDN is required. Because if you see that whenever the IP allocations, policy opening, routing changes, it takes a huge amount of days. So what it's done in a router, you are having both network the control plane and data plane over there. So data plane routes the traffic and control plane tells how to go, right? That that control plane tells how to go. And there is a management plane which basically initially doing the provisioning. So initially provisioning and other things by locally or by remote, it is done by the management plane. Now question comes, if we tell, okay, the control part which was there, you separate it and put in a common controller, right? If you put a common controller, controller can see all these things at a time and can route the traffic automatically in a particular direction. So it becomes very fast. So this is known as control plane and data plane separation. We'll see the application quite often in our next classes. Now we see the network architecture. The core architecture are based on the service-based architecture. So all are small software entities. The entire component is working over the cloud. Here the user is using the user plane. Here actually the data goes, and control plane is in the dotted line, within the dotted line. So here it is the control plane and user plane separation, your SDN architecture. And here the computing part and the data storage part has been separated. So we tell that this portion is known as a stateless network, and this portion we tell CUPS or control plane, user plane separation. So what happens? These are the basically control plane. That is for the signaling part it will handle, and actual traffic will go via this. It's having some typical advantage, and we'll see that with the cloud native networks, which is very typically doing the provisioning automatically. The 5G core is completely cloud native enabled. It's having the automated operation management, high level network, cloud network security is involved, and the 5G voice, which will be clubbed with the normal IMS core, whatever it is there, and automation and orchestration will be part of this network. So these gives our radio. Next, we'll talk about the radio network architecture. In the past, the antennas with the passive devices and all the cables were the coaxial cables. Next generation, what has happened is that this cable, coaxial cable, got removed and it has been put as an optical fiber. In the next generation, this entire thing has been combined and it is put as a smart antenna, and the entire cable which will be coming, it is a optical fiber cable. So this antenna, initially it was known as a passive antenna, now it is known as active antenna. So the migration we have seen from the single antenna, then multiple antennas, but nowadays the more important portion is the massive MIMO architecture, where all the antenna elements are distributed as we have seen earlier. And from that antenna, only the optical fiber cable comes to the distributed unit. So this unit is known as RU and the DU, and then we'll see the control plane separation in ORAN. Now this is the 5G network for the new radio, which is connected with the 5G core, and this is the LTE network and the EPC. This may not be there initially. So what will happen is this new radio, that is the 5G radio, and this existing 4G radio can be connected with the 4G core itself. And that type of deployment is known as non-standalone architecture. So operator like Airtel, Vodafone, they are doing this type of network deployment. But whenever any new network comes, so they put this, they do not have any other network. So they put G node B and the 5G core, and they connect this network. This network is known as a standalone architecture. What Jio has done, they are putting this network, and 4G network is completely separated. So they are the 4G radio and 4G core is connected like this. So they are all separated overlay network. So 5G will have the different network, 4G will be having different network. What will happen in these earlier cases, you cannot get all the facilities of whatever services you could have got in 5G. So it will be a reduced one. But here, since you are making a standalone architecture, new radio, 5G core, so you will get all the 5G services. And that's why Jio is telling it is a true 5G. Now it is a network slicing, as I told that the different type of services require different kind of resource requirements. So as you can slice your bread like this, the network also can be sliced based on the requirement. And what is that requirement? Is, say for example, a user is requiring the services like IoT services, maybe the YouTube services, maybe some AR/VR kind of services. Now, AR/VR kind of services is the low latency communication. It is the eMBB connection and it is the MMTC. 8 such type of applications can be connected on the user, and it will be going via G node B. It will be going to the core. You see the resources which were here normally, because MMTC and the high-speed communication, the resources can be located in the core itself. But for low latency communication, this is UPF, that is the user plane via which the data will actually move. This can go there because it can tolerate high latency, but it cannot tolerate high latency. So it should be there. The UPF should be as near to the user, and the local application will be loaded there itself. So based on the type of application, the resources will be getting distributed, and there will be a particular type of assistance info, that is network slice selection assistance info. And you can have, every user can have 8 such slices. And there will be an ID that is known as NSSI ID. I will show you next how it comes. So suppose there is a car type, automated car type requirement. So this NSSI will be broken into 2 parts. One is the SST, what is the select site, whether it is the connected car, and SSD type of this another discriminator, which will tell that what type of car it is. So based on that, it will take the decision, resources will be getting allocated. Say for example, in 4G, whenever the voice and data goes, the voice goes via this path and data goes via this path. And there is NB-IoT, narrowband IoT, the smart meter kind of IoT, which takes another part. But for 5G, what happens? The user sends the network slice request because he requires this type of service. So based on the type of service, the slices, core network will be sliced, the radio network will be sliced, and all the information will be intimated to handset. Handset will be passing a particular application through particular slide, like via this voice, via this data, via this game, via this smart meter, via these the different kind of services. So this is the particular thing which 5G gives. So for example, here in LTE, the YouTube or Twitter or all information goes via only one path. But here it will be going via different paths. So different kind of user planes will be getting allocated, and based on the quality of service levels, it will be connected to the different type of paths. And based on that, you can find out, okay, how much is the load for YouTube, how many customer, which customer, everything you can find out. And if there is a automated cut type of application, so mobile edge computing will come into picture. He will be as nearer to the customer as possible. So this type of network slicing, so one size does not fit for all. That the concept has been adopted over here. And now we'll go to a quick browsing for the Open RAN. So Open RAN is giving the 60% of the CapEx and OpEx because of the RAN radio access network gives the major cost, and 5G it will be much more. So what this Open RAN can significantly reduce the cost, and the capex will be coming down. So how the things are happening in the normal antenna sizes, you have seen that the RRH is coming by optical fiber, and this RRH, the radio, is having the proprietary hardware, having the proprietary interface, and having the proprietary baseband. So you have to purchase from the same vendor, right? This is the traditional RAN. In the virtualized RAN, now the radio is proprietary, interface is proprietary, but the baseband unit, you can put common off-the-shelf hardware. That is the approach towards the NFV, and the proprietary software is there. In the Open RAN, you can take this from any vendor because you are taking it from COTS hardware. You are making is the open interface, and you are making is an open hardware. So you can take from one vendor, this from one vendor, this from another vendor. All the things can be different. So cost will come down. Whoever gives at the cheaper cost, you take that. Otherwise, it was bundled and people were giving at a very high price. So what happens from the traditional RAN, if you see the radio unit, baseband unit, management unit, the cloud platform has made in the baseband platform completely in the virtual LAN. And later on in the radio network, it is completely the NFV platform, and SDN have been deployed over here. That is the control plane and user plane completely got separated, and the different apps are coming now, say for radio admission control something, handover control something. So all such things will be monitored by apps, and those will be handled in this way. So you can take the RAN unit, that is the RRHs from different vendors like ABC. You can take the baseband unit or the distributed unit from the different vendors, and similarly the control unit can be taken from different vendors, and the different services you can take from the different one. And this gives a completely orchestration, adoption of the artificial intelligence for the different type, and provisioning of every type of services can be done by the cloud native networks. So that is the major shift from the particular thing which you used to do in the 4G environment, in the restricted environment, but it is a completely different one. And here the provisioning is done lightning speed, and the cloud network enables you that the virtual machines are getting allocated for that particular service. Once it is getting done, you are coming out. So your network becomes in such a way that your antenna, your radio unit part, your distributed unit part, and control unit part are completely separate and governed by under the common orchestration platform, which is governed by artificial intelligence, right? Every operator is moving towards this Open RAN architecture. Now let us quickly browse what is the spectrum we are utilizing. This time we are utilizing 700 megahertz Jio has taken. We are taking 3.5 gigahertz spectrum, and here 100 megahertz has been allocated to each operator. And there are the two bands, basically FR1 band, frequency range 1, that is up to 6 gigahertz. And here again, 26 gigahertz and above, the frequencies have been allocated. The 26 gigahertz frequencies have been allocated, of the frequency band has been allocated. So we'll tell that what are the bands. If you see the bands, the FR1 in the very low range bands, all the Gs are possible. In the mid range, all the Gs are there. But in the higher band, millimetric wave FR2 band, which you have already discussed at the 26 gigahertz, only 5G is there. And later on, 6G will come. Of course, 6G will occupy the terahertz zone also. As you are going the higher the frequency, what will happen? The distance covered will be less. And as you are going down to the frequencies, the distance covered will be more. So if you see that in the 5G 700 megahertz and in the 4G 850 megahertz, almost it will be giving the same coverage. So the small low frequencies will be giving the higher coverage areas. And the 3.5 GC and in the 1800 4G will be giving almost same coverage. But as the frequencies are high in the millimetric range, the coverage range comes down, but the throughput becomes very, very high at about 26 gigahertz because the spectrum have been given in a different way. I will come to that. Now in FR1 band, please remember, you see your handsets, whether it is covered by N78 and N77. You can see in your settings, or you can go to your in your handset, in your settings or wherever about phone, you can take that. You can see what is your serial number of the, or if you know the serial number of it, it's not serial number, model number of the equipment, you can go to internet and you can see whether it is supported and which bands are supported. And based on that, you can see the 70, N78 and N77 bands are covering this 3.5 GC. But here in the 26 GC area, N258 and N257 bands should be there so that you can get the FR2 band, else you will not be able to handle it. Now in the spectrum, whenever FR band, it was maximum 100 megahertz can be allocated to an operator in the different formats, 5, 10, 15, 20, or like that. Similarly, in FR2, it can be allocated 50 megahertz, 100 megahertz, 200 megahertz, 400 megahertz. So Airtel has taken 400 megahertz here, and Jio has taken 2 400 and 1 200. That means 1 gigahertz band they have taken. So the throughput, as your bandwidth will be getting increased, you will be coming close to 20 gigabit speed, right? So in the higher speed, this FR2 band, only you can achieve this speed. In FR1 band, it cannot be, it will be of the order of 1 gigabit speed or so. Now in the deployment phase, or very less slides are there. So you see that the 4G and 5G will work together in NRSA. So 4G network and 5G network will be working, and your handset will be like this. In the option 3, it will be moving via LTE. So LTE phone will take this path, and 5G will be taking this path, but 5G's handset signaling will be taking this path. And in the option 7, the 5G, the normal 4G code will be replaced by the 5G, and the LTE will be upgraded to ELTE, and the paths will be like this. But once you are moving to the SA part, what will happen in SA is that it is a completely the new radio and new core. So you can support only 5G handsets, but if the handsets are 4G handsets, so that will not be supported. So what Airtel and Vodafone they have done, they have taken this intermediate path. So LTE will be taking the handset will be taking this LTE path, and 5G handsets will be taking G Node B, but they will be using the common this path. So this will be reducing the cost. But what Jio has taken a path, so they have separated. So LTE 4G network will be supported by the 4G handset, 5G networks will be supported by the 5G handsets, and this will be the path. So this is the 5G network. A typical network will be there. So there will be the different type of front haul will be there, which are basically the radio units part. Mid haul will be there, connectivity from front haul to the distributed unit path, and there will be a back haul where from the CU will be connected to the other CU, or it will be connected to the common core path. And dynamic spectrum sharing is another technology which different operators are using. So what they do is that same spectrum they are utilizing both for the 4G and 5G. Initially 4G customers will be more and 5G customers will be less. So accordingly, proportionately, they will be utilizing. But as the 4G customers will be getting reduced, 5G number of customers will be getting increased. So they will be going for the 5G spectrum will be occupied. So with these things, I want to conclude it here. And any questions, I'm ready to take from the audience. Over to Ramda.
Thank you, Chanchal, for such illuminating presentation. And your authority on the subject, having 36 years of experience in telecommunications. So we could not get a better speaker than you. For so lucidly, you have explained, starting from 1G to the dynamic spectrum sharing, everything you have told in between. So I request the audience, they can unmute themselves and ask questions to Chanchal.
So if we see the queries what they have given, somebody has given the very good compliments.
Yeah.
The best presentation done on telecommunications. Keep it up, sir. Thank you very much, Jagdisha. And we got one thing. What are the side effects of 5G? You see
Right.
that any technology is having its pros and cons. But if we see that you will be, I know that you will be talking about the basically the effect of the electromagnetic wave radiations. Now you see that for the higher frequencies, the spectrum and the government of India is very stringent for the power density measurement, which is the lowest frequency which is utilized by 2000. Right. So F by 2000 watt per square meter is the specification. Suppose the 700 megahertz which is going to be equalized, so it will become 350 milliwatt per square meter. Right? We have seen that in the measurement that this is the equipment tool, which is the Omni antenna, and this is the receiver spectrum analyzers. So if you put this, if you see the cell wise watt per square meter, if you see this is very less. This much less compared to the threshold. So you don't worry. The inter cell separates, the inter tower separation must be within the proper. They will be making a proper control so that it is coming within the threshold, and the whatever myths you are finding that doesn't have any base. It's coming just like that. And WHO, it has gone to WHO, and WHO simply summarily rejected whatever claims and other things have been given. It's like the sparrows are dying and all such things are complete nuisance, and it's nothing related to this. Because of the huge amount of deforestation, and basically the birds are not able to frame their nests, and that's why these things are happening. It is no way related to that. Let us protect our environment. With that, we can have that control. Absolutely, there is no way linked to the health hazards and others. Of course, the radiation can be more if it is crossing the threshold. But all operators are keeping their control, and DOT's term cell is completely vigilant over there, and they are taking the periodic data from that. And if somebody is trying to reduce intentionally during the measurement and pre and post, they find that if something is done, that when the measurement is taken, at that time they are reducing, after that they are increasing, the huge penalty will be imposed. So the operators are now, or it may be liable for the cancellation of their license. A huge penalty also may be imposed. So nobody is daring nowadays to do that. So Mr. Anil has told, thank you, Mr. Chanchal, for a best presentation. Thank you very much. And this gives us inspiration for further doing the different kind of. So what about radiation and EMF work occurring? As I've already told, I have shown you that is F by 2000. In other countries, it is F by 200. Government of India has reduced 1/10 of the whatever other advanced countries are doing. So you be rest assured. And if the F by 2000 is the watt per square meter, so that is the power measurement is being done. And since the lowest frequency will be utilized here, the 700 megahertz, as I told, it will be 350 milliwatt per square meter measurement. And with the measurements which are done by the operator, It is done periodically. Periodically, it has to be sent before radiating any site. People have to make sure that the EMF clearance is done. So there will be a self-certification. Self-certification is done and DOT periodically checks that. It has to be submitted to DOT portal, and the DOT periodically checks that. If there is any anomaly at any point of time, each penalty will be imposed on the RE. So you don't worry for the electromagnetic EMF is concerned. Will it not be better to restrict the convenience of human beings and restrict 5G application only for the space research, medical field, electrical power generations? Here I want to tell, see, the innovations or technology cannot be prevented by any means. Technology will be there. People have to find out the ways and means, the way I have told, that it can be put under disaster control. It can be placed for the places where human lives are endangered. You can put in the agriculture for the different type of education, like holographic presence by the, then you can do the robotic surgery. Then you can have automated car movement, the traffic movement, the health support, and all such supports, anything and everything which improves the human life. And that's all up to us. We have to devise. There are the different applications are nowadays coming. You know, the society rejects some applications if it is not suitable for society. You must have seen that 3G has been summarily rejected in our country because 3G ambience was not there, 3G application was not there. But before launching 5G, the 5G ecosystems have been seen in terms of application, in terms of the device availability, in terms of the cost reduction. That is a very good thing. And it is due to the Make India and approach, the different, the people are coming forward to manufacture the handsets. And the most important part, that the chips are going to be manufactured in the next 2 years down the line. So that will be reducing the IoT cost and the device cost like anything. So definitely you can see that these applications which you are restricting, it can be put on the different applications like smart city, smart traffic, smart health monitoring, smart grid, smart meter, and any such smart things. But we have to be smart enough to adopt to which particular applications we need to take, and we need to reject which are not suitable for the human beings for its existence. Will it not be better to have thorough study about the side effects before implementing? This has been given a huge trial in the different countries with the regulatory authorities, with the IITs, with the different school of medicines, with the WHO worldwide. And it has been seen that it is not at all detrimental to the health per se, provided all operators are to be aligned in such a way. You put more number of sites, but you reduce the coverage area, so that it should not overlap the coverage, and it should not have the huge coverage to these things. But you please be ensured that this type of radiation which is happening over here, it is not ionized radiation. It is a non-ionized radiation. There is no way that the power which will be coming in this microwave range, it will be breaking down the molecules of your cell. No way. So it is a non-ionized radiation, and it has been approved by the different school of medicines, different technology institutes, all the eminent technology institutes of our country and abroad, and the doctors, the regulatory authorities. So you be rest assured. Avirup has complimented these things, sir. The presentation is best for knowing 5G overview. Thank you very much. This presentation, I have included many learnings from whatever I have seen in the IMC. I was there in IMC for 4 days, and from the inauguration till the closure, and the different learnings, different photographs, different things, whatever I've collected. So I tried to incorporate those and try to enhance the learning for. So this is for your for you. Thank you, sir, for the informative presentations. Thank you for your compliments. So this will be, again, I am telling you, this gives us the pleasure of we get the impetus of doing further better in future, and will be putting in future the different type of the technology irrespective of no vendor associated, no operator associated. It is only the technology presentation. Our endeavor is to inform you what is the technology, plus, minus, whatever it might be. And different operators are implementing in a different way. Like that, I told operator like Vodafone and Airtel, they are going for the NSA architecture, and Jio is making the SA architecture. It is that's why I told all kind of architectures, and everybody is doing in a different way. That is their own thought process, their own the way of implementations. And BSNL is doing 4G, and after that the network will be upgradable to automatically to 5G. The way they are implementing, as I have been told. So this is the way everybody is doing, and you must be seeing in the pockets like Reliance Jio, Airtel, they are doing some pockets of the 5G, and obviously they have adopted the people like automatically they are having indications that where the 5G handset concentrations are more. So they are putting 5G G Node B in those areas, and those will be started working, and the beta testing is happening. A lot of issues are still there, but anyways, there are the pros and cons will be there for every operators. Initially, the four, for your knowledge, the four cities have been taken by Reliance Jio, like Calcutta, Delhi, Mumbai, Varanasi. Chennai has been dropped at this moment, but Chennai will come soon. And Airtel has taken around 8 towns and subsequent all towns. And everybody will be making, as had been told, equivocally in the IMC platform, that by 2023, generally majority of the operators will be covering the majority of the areas across India. So definitely with this thing, with the improvement in the ecosystem in terms of handset, the reduction of the handset price cost, and the the enrichment in terms of the types of application, it will be giving the real 5G platform, and the 5G is a reality at this moment. Any
I
questions?
can see Engineer B. Nagendra Nayak has raised his hand.
Yeah,
Mr. Nayak, will you be kind enough to unmute yourself and ask the question if you have? Engineer B. Nagendra Nayak. Okay, I think we already behind schedule by 5 minutes. May I request our honorary secretary, Professor Dr. Rajiv Bashak, to propose vote of thanks. Professor Bashak.
Yes, is it audible?
Yes, we can hear you, Raju.
Oh, yes. Thank you very much. Thank you very much, Engineer Chanchal Chakraborty, for giving me the opportunity. So it is my proud privilege to extend my sincere thanks and gratitude to all the distinguished participants in this technical webinar on the theme 5G, a reality now, organized by the Electronics and Telecommunication Engineering Division, West Bengal State Center, IEI, in this online platform. So at the outset, my sincere thanks also goes to the panelists, Mr. Chanchal Chakraborty, ED and member of the board, ATMI Private Limited. Thank you, sir. Thank you for your nice presentation. Very nice presentation, I would like to say.
Thank you very
Mr. Santosh Gupta,
Unfortunately,
Program
Santosh
Manager,
could not participate
Middle East and East and Africa region, Ericsson. My sincere thanks also goes to Dr. Nirmal Das, Chairman, West Bengal State Center, IEI, Dr. H.O. Thackeray, President, IEI, Mr. Sandeep Kumar Dev, Vice President, IEI, Professor Dr. Girish Sri Kishan Munda Dada, Chairman, Electronics and Telecommunication Engineering. And Mr. Ramchandra Chakraborty, Joint Honorary Secretary, West Bengal State Center IEI, and the moderator of this program. Thank you, sir. My vote of thanks also goes to all the members of the council and the division board members of ETDV, all the members of the committee West Bengal State Center IEI, and all the members of Electronic Telecommunication Engineering Divisional Subcommittees, Director Technical IEI, and his team for their wholehearted support to make the program grand success. Last but not the least, my sincere thanks also goes to all the persons who are behind the screen and giving their silent support to make the program a success. Thank you all. With this, we are concluding the session, today's session here, and good night to all.
Thank you, Raju. And thanks for your proposal, vote of thanks. And we shall meet on our 17th monthly webinar in the month of November. Thank you so much
Thank you,
for
sir.
participation.
Thank you very much.
Okay. So, Chanchal, should I close it?
Yeah, I think you can close.
Okay.